Hello students, so today I am going to discuss some problems from HALOALKANE HALOARENS. So at first pause the video and try to solve by yourself. If it's done, and then after that try watch this solution. Okay, so now it's time to discuss the first question. So the first question says that the reaction of C6H5CH2 beer with aqueous sodium hydroxide follows. So the option given like SN1 mechanism, SN2 mechanism, and it depends upon temperature and set J rules. So basically they want to know from you that how one can solve this problem. Uh, Not only that, how this reaction proceeds. Okay. So at first, try to draw the reactant, that is C6H5CH2 beer. So that is nothing but this, correct? CH2 beer. So you know that what is this? Now, it is nothing but your benzyl bromide, correct? This is nothing but your benzyl bromide. So this functional group we called as a benzyl functional group. So as you know that benzyl bromide or benzyl compound is not able to perform SN2 reaction because um, you know they are very much keen to perform SN1 reaction because if the living group leaves, that Br leaves, then it forms carbocation, correct? This is essentially the first step of any SN1 reaction, CH2 plus. So this carbocation forms, and these carbocations is very much stabilized. This carbocation is very much stabilized by the pi electron density of benzene. So this carbocation is stabilized by pi electrons of benzene. So you can draw several resonance structure of that, but for to solve MCQ reaction that's not needed, but to do practice you can draw several resonating structure of this carbocation. Okay, so if you know that if the after leaving the living group, if the carbocation is being stable, so then the reaction always follows what SN1 mechanism. So you know that benzyl bromide is always follow benzyl bromide always follows SN1 path, always follows SN1 pathway. Please try to get this answer. So the option A is the correct one. Okay. Then the next one. So next one says the question 2 says that the allylic bromination is carried out by some options given like HBr, H2O2, HOBr, Br2CS2 and NBS. So as you know that allylic and benzylic bromination. So essentially now what is the allylic group? Now the essentially the allylic group is basically this one, correct? This one is basically allylic group, and um, so, and what is benzylic? I discussed a few discussed in the previous slide. What is benzylic group? Okay, so in allylic and benzylic case, please try to memorize this for allylic and benzylic bromination. Allylic or benzylic bromination, not only bromination, allylic or benzylic. Uh, okay, so only bromination, not only, no, it's only bromination is uh, allylic or benzylic bromination is performed by NBS. Okay, so NBS is essentially the reagent which are used for the allylic or benzylic bromination. Okay, so if you have like CH2 double bond CH CH. Okay, so then if you add, so this is the allylic group and this is the allylic position. So if you add NBS and light source, so then you get CH2 double bond CH2Br. So this one is essentially the tails in this MCQ. Okay, so NBS is the correct option. Okay, so after that, the question 3, that is a pretty straightforward one. So they says that which of the following is a gem dihalide. So you have to know first that what is the gem dihalide and what is gem dihalide and what is vicinal dihalide. So please try to remember that gem dihalide is that one that if a carbon has two uh, same group in a particular if a compound have the same group in a particular carbon, then that is called gem. And if group has in uh, two adjacent carbons, so then that is called vicinal. Okay, so gem means same group in a carbon, same group in same two groups in carbon, but vicinal means two groups into adjacent carbon. So that is the meaning of vicinal and that is the meaning of geminal or gem. Okay, so as you know that ethylene dichloride means now if I draw, it's not essential to draw all the structures, but for you I will draw them. Just a second, I will draw them. So see, for ethylene dichloride, so this is the structure of ethylene, CH3 CH3 ethylene. So CH this is CH3 CH3 is ethane, so CHCl. So there is a structure of ethylene dichloride, but you see that two chlorine and are two adjacent positions, so that is not the case of gem dihalide. Okay, so in the case of 2,2, so you can able to know that 2,2 means two chlorine and present in carbon number 2. So that is the case of geminal, correct? So two chlorine are present. So suppose this is your carbon number 2 and two chlorine in present on that. So that is essentially your geminal dihalide. Okay. After that, they says which of the following represents Wood's fatigue reaction. So they given four reactions, and they said of which of the following is a Wood's fatigue reaction. So please read the question carefully. They said about Wood's fatigue reaction, not Wood's reaction. So please read the question carefully. Not only for that question, so it's essential for all questions, not for every questions you faced in your life. So please at first task is to do practice of reading questions. So that's the basic practice to do good score in your exam. So okay, so then what is the example of Wurtz fatigue reaction? So if you know what is a Wurtz reaction and Wurtz fatigue reaction, I will go some class slides. So just a second, I will go some slides which I used in class. Okay, so see, this is the example of Wood's reaction. So in Wood's reaction, if you see, I will not mention that. I will not mention the stoichiometry. So that is essentially two. So that is essentially the same haloalkane or haloarenes group used. Haloalkane or haloarenes groups used to uh, attach them. So that is essentially Wood's reaction. And what about Wood's reaction, Wood's fatigue reaction? Now that is essentially your Wood's fatigue reaction. In Wood's fatigue reaction, you see that's the this is the haloarenes and this is the haloalkane, but they are different, correct? They are different. In Wood's fatigue, two haloalkane or haloarenes, they are same reaction. In Wood's, two haloalkane or haloarenes, they are same, but in Wood's fatigue, that these haloalkanes are different. Okay, so please go through the class note, and then only you can get the correct answer for all this MCQ. So please see here. Here you see, unlike just a second. Okay, so here you see like in these reactions the option A, like C6H5I and CS3I, so they are different, correct? So they are different and they are attached, like you can say like for Woods fatigue reaction the case is, you can say like that, the for Woods fatigue reaction the case is Rx plus 2 Na plus R prime X. So R or R prime is different. So then it combines to R and prime. That is the case of Wurtz-Fittig. Okay. For Wurtz reaction, the case is Rx plus 2 Na plus Rx. So R and R are same, correct? So they give R and R. So essentially the option A is the correct option. Okay. Please go to the class now to better clarification, to get better clarification. Okay. Okay, so the question number 5 is essentially as I have nothing to tell for that question, so you have to know this reaction. So essentially, this is the correct option for this question is option B. Okay, if you go this reaction, okay, so you have to read your NCERT book to know about this. So please read it carefully. Okay, so then question number 6, the question number C says that the chlorination of methane proceeds by, okay, so chlorination of methane, okay, just a second, I have to check that it's recording or not, so it's recording, fine. Okay, so chlorination of methane proceeds by which pathway, like electrophilic substitution, nucleophilic substitution, free radical mechanism, which of them is correct one? You have to know that unless and until you cannot able to do the correct option, I said that the free radical mechanism is the correct option. Okay, so how can you blow like methane? So there is the methane, and if you use Cl2 and H nu, you got first time you got CH3Cl. So how did this happen? Like C, that is the essentially the correct structure of methane tetrahedral. You know that, and here there is a Cl. So after there is a homolytic cleavage happens, and here also the cleavage happens. So this forms Cl dot plus Cl dots, that is the homolytic cleavage. Okay, there is a homolytic cleavage, and this one is attached to it this carbon, so there is a heterolytic cleavage happens. So these are attached to one carbon and this chlorine attached to HCl, so you essentially got CH3Cl plus HCl. So then further another hydrogen is substituted by Cl, so you know that like this is the free radical mechanism. Okay, then it's a assertion reasoning question, so it's essentially a very good question, so please read that the assertion says that KCN reacts with methyl cyanide to give methyl isocyanate, and Cn minus is an ambident nucleophile, and the reason says that. Okay, so I think you go through this reaction that if you use like methyl chloride as a substrate, and if you add KCN, if you add KCN, then you got CH3CN. But if you add AgCN, then you got CH3NC. Okay, so there is a current reason that how this happens. So that is based on Hassaf theory, that is essentially a hard and soft acid base theory. So that is beyond our scope. I will discuss this later if time permits. So that is not the case for class 12 codes. So so you have to remember that methyl chloride, not methyl chloride, any alkyl chloride, if it reacts with KCN, so that essentially gives you alkyl cyanide. So that essentially gives you cyanide. Okay, but if you react with AgCN, so then it essentially gives you isocyanate. So you can able to know that the assertion portion is not correct, that the assertion is not correct. Okay, so but Cn minus is an ambident nucleophile, so it's a correct option, like Cn minus. So if you go like Cn minus, so it can bind through carbonate or it can bind through nitrogenate. When it binds with carbonates, so then cyanide forms, and when it binds with nitrogen end, then isocyanate forms. So it can bind through carbonate and nitrogen both. So that's why Cn minus is called as an ambident nucleophile. So the reason is correct. So the assertion A is incorrect, but the R reason is correct. So option D is the correct option for this question. Okay. Okay. So now the last one. So I will not repeat the options. The options are same like A, B, C, D. That is a pretty like options for assertion reasoning question. So the assertion says that hydrolysis of -2 bromo octane proceeds with inversion of configuration. Okay, good. The reaction proceeds to the formation of carbocation. Okay, so now try to draw that 2 bromo octane. Okay, so I'll draw this in a linear fashion at first. So octane means 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. So 2 bromo means this is a true. Okay, so I'll not fill with a hydrogen, so but you can. So this is CS3, here is H, and there is the rest part. Like okay, okay, I'll do that for you. Okay, just a second, just CH3, CH2, 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 CH2. So this one is basically your chiral carbon. So I'll draw like this. So see this one like CH3, not CH3. This one is 1, 2, 3, 4, 5, 6. C6, H, 2, 4, 6, 7, 8, 9, 10, and 30. Okay. And suppose I placed uh, the Br in the above. Okay. Hydrogen in the below and CH3 here. So this is the correct representation of 2 bromo octane. I don't know that is a -1 or +1. So that is the experimental thing. In theory, I cannot predict that is a -1 or +1. But let's say, but if you consider that this one is essentially goes through a inversion of configuration, correct. So inversion of configuration means the hydrolysis of OH minus attacks and Br minus leaves out. So if it follows SN2 pathway, then inversion happens, correct. If SN2 pathway follows, so then inversion of configuration happens, and if SN1 pathway follows, then racemic mixture will form. Okay, so if SN2 pathway follows, then ki hoy na, then inversion happens, and if SN1 goes this, then racemic mixture forms. Then racemic mixture forms, correct. Okay, so here if OH minus attacks and Br minus leaves out, if it will follow SN2 pathway, then what will form? C6H13, CH3, then OH minus goes below and hydrogen goes above. Okay, so then inversion happens. Okay, so inversion happens, that is true. So inversion happens when SN2 pathway follows, correct. So if SN2 pathway follows, if SN2 pathway, so this one is basically true. Okay, so the reaction proceeds through the formation of carbocation, but we know that formation of carbocations is only happened in the case of SN1 pathway. Okay, the carbocation formation is only happen for the SN1 pathway. For SN2 pathway, there is a one step reaction. The nucleophile attacks and leaving group leaves out. That is a one step reaction. So there is no formation of carbocation. So if there is a formation of carbocation, then the inversion of configuration doesn't happen. So in the case of that is what now, that is a racemic mixture forms. So the reason is not correct. Okay, so the assertion is correct but not the reason. So the assertion is correct but not R, so like you say that option C is the correct option. Okay, so thank you for watching.